This episode is sponsored by Swagelok.
Managing hydrogen safely and cost-effectively while meeting performance benchmarks and reducing downtime is critical to building a sustainable clean energy future. That's why industry leaders trust Swagelok. With Swagelok, your team is a lot bigger. You have access to hundreds of fluid systems experts around the world who can keep you and your systems online and operating efficiently. Learn more at swagelok.com/alongside you.
Hello and welcome to the 1895 podcast with me, Thomas D.
And me, Rob Cockerill.
Rob, back in the studio, coming off the back of that financial podcast last week. Interesting to pick over those financial results and sort of sort the wheat from the chaff there.
Yeah, absolutely. Great deep dive. And as we said, look forward to more. And it got me thinking, Tom, actually, we talked about numbers a lot in that episode. This is, more than 60 pods now, isn't it?
Well, this is episode 61, in fact.
Oh.
So, yeah, we're really ramping up, aren't we?
We've got a long way to go to get to 1895, but, you know, we're
one day
through.
We'll get there. But for this 61st episode, I think we should return to the theme of hydrogen and perhaps scaling the hydrogen infrastructure. We talk a lot about sort of the regulatory side of things, the political side of things, and especially the financial side of things. But there's a technical side of this as well, isn't there?
Yeah, absolutely. And how do we make it happen? And that's something, you know, we've asked a lot at Gasworld and H2View through the years, isn't it? How do we make hydrogen happen? So that will be a good question, I think.
And joining us for this conversation is going to be Chuck Hayes, Global Technical Lead of Clean Energy at Swagelok. We've heard from Chuck a few times. We've heard from Swagelok a few times over the last year or two. So always great to get them on the podcast, isn't it?
Yeah, it is. Yeah, very knowledgeable, absolutely knowledgeable, and experts in their fields. That's fantastic. And we always get a lot of technical value out of these episodes as well, don't we?
We certainly do. Before we get Chuck into the room onto the podcast here, what are you hoping to hear from this conversation? What do you want to get out of Chuck?
Well, I think in addition to all of that technical value and expertise, we know Chuck travels a lot, so I really want to ask him about the good, the bad and the ugly of hydrogen. We've talked a lot about it in recent months. I'd like to know, how he's finding it on the ground, with those boots on the ground, and where it's happening. And on that note, I want to know where in the world he sees the current growth hotspots, because as I said, we know he travels a lot, we travel a lot, Tom. So it'd be good to see if all those stories correlate. But we know we're also going to have a series of regional or country specials of the pod coming up. So it'd be great to find out what he thinks.
Yes, and depending on where he says, maybe this will help guide us for where we look for these stories and where we look for this upcoming hydrogen industry.
Yeah, how about you? Is it the technical side?
For me, it's a lot on the technical side. We know all the work that Swagelok are doing on this technical side. So really how they're scaling from their point of view and the role that they're playing in making, I guess, this able hydrogen infrastructure and how we're going to go forward from here.
Fantastic.
And I guess with that, we should welcome Chuck to the podcast.
Yeah, let's get him into the studio.
And we're delighted to now be joined by Chuck Hayes, Global Technical Lead of Clean Energy at Swagelok. Chuck, thank you for once again joining us on the 1895 podcast. It's been a little while since you've joined us now, hasn't it?
It's been quite a while, hasn't it?
6 months or so. So perhaps you could just update us with what's new with you, what's new with Swagelok, and how have the last few months been?
The last few months have been busy. We've been out working with customers, helping them find solutions and recognizing some trends. And that's kind of why I picked this topic for today, because it's a trend I'm seeing as people are developing in the hydrogen world about being able to start scaling and going up in scale as they want to develop and become larger and be able to support the market. So that's something new we've been seeing, and we're going to have to talk about it.
Yeah, absolutely. I mean, the scaling of hydrogen infrastructure is something that we seem to be covering a lot here on H2View and Gasworld, across our webinars, podcasts, in our magazine, online. It's everywhere, isn't it?
It is indeed. In fact, Chuck, I wanted to say before we get into the actual kind of nitty-gritty questions there on that topic, just anecdotally, as Tom said, we haven't spoken to you for several months now. So how are you finding things in this hydrogen market? How's it looking? How's it shaping up on the ground?
Depends on where you're at. So right now, North America, especially in the U.S., has issues of uncertainty due to some of the political changes. It Europe is stable, but slower than expected for some of the take up, and that has to do with just delivering hydrogen to where it needs to go. And that's being done a lot through pipelining right now, and that process takes a while to get those built. But it's still moving fairly steadily. Asia, some areas in Asia are taking off like crazy. So we were in Indonesia a few weeks ago, and they introduced a nationwide strategy and 50 memorandums of understandings with different companies to start building out hydrogen and hydrogen infrastructure. So places like that are really starting to go. And of course, Japan, China, Korea, and India now coming up the scale really quickly. So we're seeing a lot of development quickly in some areas, and some other areas are either slow, steady, or kind of scaling back the speed in which it's going to go.
So that's very consistent with some of our recent episodes, Tom, isn't it?
Yeah, absolutely. And you mentioned those political challenges and those political changes there, and perhaps we can get into that a little later. But as you've said, it's been a busy start to the year for you. You travel around the world a lot. You've just got back from Italy. You get to see plenty of hydrogen customers that are entering the market. So is there anything that you're seeing in common between all of these companies?
There's actually two trends. There's one which we have the people that have been involved for years and years and years, and they're slow and steady, oftentimes larger companies. And then we have new startups that are really anxious to get in, just like any new industry. A lot of startup companies come. Some of them have great technology, but not a lot of knowledge on how to bring it to market. And that's been a challenge, and that's a place we can come and help them in being fluid system experts.
And are those newbies still coming, Chuck? Are they still coming in great numbers as we saw in recent years?
Again, it kind of depends on where you're at. So the development in North America primarily is venture capital and small companies having a dream and wanting to start. In Europe, it's a little bit different. A lot of times it will come through and in England especially, they come through collaborations often with universities. So universities and businesses get together, they start collaborating, and I think when you put it together, college professors probably aren't the best people to set up production in a facility. They've got a different level of expertise. So sometimes those are the folks that find the biggest challenges.
But maybe I should rephrase that, Chuck, and say not so much are they still coming. Are they still coming with the same energy, the same gusto, the same kind of verve? Or because Tom and I have discussed in recent episodes, it feels like the shine has gone off the market just a little bit. But are they still coming with great enthusiasm?
Yes, some are. It's the gold rush. I think is over. That first rush going to try to make your millions really quickly. But the people that are coming feel that they have something to offer the market, and they're willing to come in and risk it all to be able to get there.
Sure, and of course, all these new entries into the market are going to help with the scaling of hydrogen production. So where do we stand right now in terms of scaling hydrogen production, given that we are in June 2025?
So one of the biggest problems we have, there's a lot of hydrogen being made in the world. There has been for years, but that's primarily already all the offtakes for those have been called for. So used a lot in oil and gas manufacturing, hydrocrackers, different processes where it's been used industrially around the world. So now the problem is we don't have enough gas where we need it. And that's been the challenge, figuring out how to get it where we need to go. It's expensive to compress and put onto tube trailers. So there's been a large conversation of do we go cryogenic or do we go cryocompressed to be able to move more molecules in the same size truck, longer distances, without having to pay that price for compression. Of course, there's a price for liquefying as well. So those are a lot of the conversations that are coming in. I think the really big case study was a case study of a major truck company in California or in Arizona that folded this year, primarily because they didn't have infrastructure to sell trucks for. So they have trucks. They were able to build hundreds a month. They were ready to go, and there just wasn't stations. They were planning on going into California in the U.S. primarily, and California promised 250 stations by the end of last year, and there were only, I believe, 87 complete. So there was no place to fuel, so nobody needed the trucks. And that's where the problem is coming in, is making sure we've got both vehicles and and fuel where it's needed for those parts of the infrastructure. The second piece is those industrial uses like steel, glass, cement. If they're going to convert over, they have to have a guaranteed steady state of hydrogen. So steel plants are looking at, Germany's already run steel with pure hydrogen as their heat source. There are a couple places in the U.S. that are heading that direction. Japan is heading in that direction. It's just making sure they've got enough of the gas when they need it, where they need it to be able to go.
Absolutely. Still talking about the chicken and egg in many ways, aren't we, Tom?
Yeah, we really are.
Unfortunately.
And off the back of that, we've spoken a little about this on previous podcasts, even with you guys at Swagelok. But when it comes to hydrogen infrastructure, are there any lessons that we can take from existing or legacy infrastructure, if you want to call it that, when it does come to designing, deploying and expanding hydrogen systems and the infrastructure surrounding it?
I think one of the biggest things is really making sure we've got our local authorities trained. Don't just come in and try to put in a station. And that station or that infrastructure will have to be approved by an individual called an authority having jurisdiction. It's different everywhere you go. In different countries, in parts of Europe, of course, that would be your TÜVs and agencies like that. In the U.S., every single state, every one of our 50 states has a different scenario for how they do that. And I think one of the worst ones can be in some places like Ohio, where we are, it's the local fire chief. So you have a local fire chief who has no experience in industrial gases that needs to somehow understand thousands of pages of regulations to be able to approve a station. And that can become either a very easy process because they really don't have the training on what to do, or a very difficult process because they're afraid to release it. That was part of the problem in California. Every single town they went into, they had different rules. And until we have those, we have standards, but until we get the states to be able to make it easier to be able to put in stations, put in infrastructure, put in refueling stations, build facilities, it's just difficult. And that's happening everywhere. So I say a case example being someplace like Indonesia, that we were just seeing how they were approaching it, and they were approaching it from government helping on all aspects. Right out of the gate, having ministers involved to make sure it was easy to permit, easy to get items through. Germany has had a special council on permitting to help make it easier to permit. And that's going to make a big difference everywhere. So we just you can't get to the starting line and not have anybody start the race. So that makes it very, very difficult.
As those regulatory and political challenges come into the fore again, isn't it?
It is, and it is knowledge and understanding and awareness. Interestingly, a few hours before we actually sat down to do this, I was thinking about this interview, and I thought that one of the biggest challenges actually is, look, it took a century to build up the infrastructure we have now, as so often gets said. But that was the only. It was the only fuel or infrastructure where, in terms of starting the race, there wasn't, we were all running in the same direction. It was the same race. Whereas now it's, we don't need to do these things necessarily. So we're not.
And we can't expect the hydrogen infrastructure to scale up at 10 times the speed as what we're used to.
Yeah, exactly. So it's got a very difficult challenge, but that's why we need these conversations. We need these specialists like Swagelok and all the stakeholders involved to make it happen. But so let's come back to the topic, Chuck. Sorry, that was my tangent there. In terms of the infrastructure, so from a Swagelok perspective, what are the biggest challenges to scaling from a fluid system point of view?
So one other part of scaling besides industry-wide is individually within individual companies. So let's take an example. Let's say I had a small company that was making either dispensers, or we'll go with electrolyzers because they've got a lot of different challenges. And electrolyzers, building an electrolyzer stack is not terribly difficult. Making a very efficient one is difficult, but making a stack is not difficult. Setting up the balance of plant can be difficult. To do your water purification, your separation and final purification of your hydrogen at the end, making sure that everything is running efficiently. So there's electronics involved, there's gases involved, and having that fluid handling. Now, you can go ahead and plumb up a system by hand and get it all to work. And we'll see companies that do this. And you'll come in and they'll be like, well, we did proof of concept 2 years ago and built one or two systems. And then we built 3 systems last year. And we're like, okay, where do you plan on being next year? And they'll say, we want to make 500. How are you going to do that? That is always our question. They're in a small building, 1,000 square meters, and they've got 5 employees, and they have these ambitious goals to go into these large scale productions. And that's kind of where we come in and we can help. So we can do things at Swagelok in the fluid system area. We're not going to do anything in the electronics area, but things like a very perfect example. Every single electrolyzer has sampling panels on it. So what they're going to sample is the purity of the hydrogen coming off of the electrolyzer stack and look at what kind of crossover of oxygen they have in the hydrogen stream. And those panels have 40, 50 devices on them, as well as an analyzer. And we are experts in developing sampling panels. Let us go ahead and do that for you. We'll deliver it with one part number, 2 connections already tested and ready to go, and you just pop it in. It's one less thing you need to work on. Another example is just tubing runs and fitting designs and so forth. I've seen manifolds built that are partially welded, partially threaded, partially the 2-ferrule connections, and frankly, they'll work, but they're not as elegant as they could be. Let's put it that way. So we have the ability to go ahead and help redesign those, make them more efficient, make it so that when you get down the road, you're going to have a much more efficient design of your systems. And then the other thing we see a lot of is just mixing of technologies. Like I said, threaded connections, pipe connections, tube connections, all together on the same design. And what that's going to make is it's going to make maintenance a nightmare later on. So we can help streamline those as you start scaling, help bring things in, like bring in kits. So you're going to run this thing in 5 stations as you build it. We can bring in everything for any one of the stations in one kit. You have everything right there where you need it at all times. And then we offer other things. We offer things like vendor managed inventory. We can actually have full inventory on your site that when you need it, you can just go pull a fitting out of a drawer. You don't have to do a PO. You don't have to call. You don't have to wait for it to get there. It's there. You don't get charged until we come back and count and see that you've used it. So all these different types of things are things that just make it faster and easier to do business. Nothing worse than having to wait for one piece to show up to be able to finish part of a build. And those are the type of things that we offer as we move forward. And then there's other things. So once you get through that whole set of the process, we can do, again, design analysis and optimization. We can deliver components and kits. We can deliver pre-done panels and pre-bent and swage tubing. So it just pops in. You don't have to bend it, and we do that with CNC benders. So you get everything to fit. And then finally, when it comes time to get it installed on site, we can be there and do oversight. So we can actually be there and help monitor to make sure your installation team, and that's usually a contractor, not the parent company, that's doing it is doing it right. We can also train that team. So we have training in hydrogen for designers. We have a 2-day course for hydrogen design. We have a 2-day course for hydrogen installation that we can do globally as well. So we can train your team that you're hiring to be able to do installs, and that encircles your entire build and your entire deployment to take care of a lot of those snag points that are out there.
Sure, and we recently discussed sort of education and workforce upskilling in a previous episode with Swagelok. So listeners, do be sure to go back and listen to that wherever you get your podcast. But staying on Swagelok and what you offer, I want to talk about purge systems and the role that they play. So what part do they play in scaling up hydrogen production and extending that hydrogen infrastructure?
It's really important. So basically, people don't often think about their purge systems. So the purge system is critical because I like to say, because it makes it simple, hydrogen plus oxygen equals rocket fuel. Hydrogen and oxygen took us to the moon. It will take us to Mars in second stages of all the rockets. That's a very, very powerful combination. So you don't want to break into a system that has hydrogen at pressure ever. You want to drain your system, but that's not enough. After you drain it, you want to go through a 5-step process. Drain out the hydrogen, go ahead and purge it out with nitrogen. Then you open your system and let air in, and that has oxygen with it. So then you have to purge out the air, and then you can finally bring your hydrogen back in. So it's a fairly simple round to be able to do that. The trick is that people don't often plan for how to do that. or plan where they're going to connect and how to make that system work. So we offer, this is something else we do quite a bit, and we have panels that go into every aspect of that. So you're going to bring in a 12-pack of nitrogen, or two of them actually, one in backup, and we have a panel that does an automatic changeover. So when the one gets down too low, it switches over to the next. We have ways to make sure you don't pull hydrogen back into your oxygen supplies with other panels that control that purging process, and then single point of use panels and regulation to be able to make sure everything is working properly. And again, those are all single part numbers. Just have us come over. We'll make sure we have everything lined up properly, give you the part number, can make the same exact part anywhere in the world. You don't have to order, you don't have to try to build those in-house. They're already done, they're pre-designed, and it makes it really simple. And then we can go ahead and make sure your systems are safe and you're safely handling the hydrogen when it's there. We had a recent example of a professor that was working with hydrogen, and he found out about this, and he said it was the greatest thing because he doesn't have to hire an engineering firm to design up the panels he needs for purging, and then he doesn't need to hire a procurement company to go buy all the parts. He just orders one part number from us, and it's delivered, and it's done. So that makes life a lot easier, and it makes things faster, both in production and through the design process.
Sure, absolutely.
Yeah, fantastic, Chuck. Now, the next question, I mean, you've already given us a number of ways in which we can make things faster and easier. I'm thinking here about, providing all of the parts and the components and the kits that you talked about, the expertise, the skills that you and Tom both mentioned. But, essentially a one-stop shop, really making that happen. But in what other ways can a supplier make the whole area of scaling easier for hydrogen OEMs? What other things can you do, or what other factors should we think about?
Well, so one thing about Swagelok, we've really made a major transition over the years that we don't just provide a little blue and white boxes with parts in them. We can if that's what you want, but we are a full solutions provider. So we not only do we help with design. We've got, I think, close to 80 field engineers around the world fully trained in hydrogen that can come on site and offer recommendations. We have a large staff throughout all of our sales and service centers being able to build panels and build solutions. But we can also even help with how to lay out your plant. We've got expertise in lean manufacturing. We can help offer suggestions on how to make that scalability. How do you make 10 people make 10 people do the work of 20, just by simple changes on your production floor and simple changes on the way you're bringing in parts. Let's face it, the labor market everywhere in the world is tight right now, and getting anybody that's skilled is even more difficult. So how do you do more with less? And those are the types of things our expertise helps customers get to. Really, the last part of our conversation is typically what parts we're putting in. Now, when we do talk about parts, we have spent quite a bit of time, and we continue to develop components specifically for hydrogen, making sure that they've got the right materials of construction, they've got the right lubrications. That's one people miss a lot, is making sure you've got the right lubrications so you're not contaminating the gas, and making sure that everything is sized appropriately. And sizing becomes one last thing that's really important. People often use sizing calculators for tube sizes that are used in oil and gas. That's a problem because what it leads to way oversized systems in hydrogen. We find often people building 1 and 2 inch systems, 22 to millimeters and larger, that could really be 12 millimeter half-inch systems, because we can take velocities faster in hydrogen due to the nature of how that hydrogen gas works and the fact that it's clean. We don't have to worry about things like erosional velocity. So that's one area that we find ourselves in all the time, of helping people not oversize, because oversizing gets expensive. It's hard to seal a small molecule gas. As you keep making the areas you need to seal larger and larger, the force needed to seal is still the same per square millimeter, centimeter, whatever you want to call it. That process of sealing becomes more and more difficult the larger you get. So keeping the system small, keeping them compact and elegant is really the goal.
Yeah, and that question's got me thinking about industry innovation as well. So is there any, innovations that you're involved in or you're seeing in the industry that would enable not only faster but also more cost-effective scaling up of the hydrogen industry and the infrastructure?
There's new components coming. We're working on some, but we're not really ready to talk about those yet. We've just released a new check valve developed specifically for high pressure hydrogen. And I think the biggest place the industry is really coming to the grips and understanding that where we stand right now is a critical junction to be able to make products that are going to last for a long time. We have to be very aware not to design systems like they're going into oil and gas. Oil and gas systems use these things like pressure relief valves absolutely everywhere. They use double block and bleeds everywhere on their systems. And in hydrogen, we want to build it with the least number of components possible. Yes, I work for a company that sells valves and fittings, and I want to sell you the least I can to make your system do what it needs to do, because that leaves you with less leak or possibilities of leaks. We have to calculate a standard leak rate for every component, no matter what. And that's part of the safety protocols. So the less you have, the better off you are. And those things are the types of things. Simpler, cleaner designs are the best ways to go. Smaller installs. I think one of the biggest things we are seeing, we're going to see some new innovations coming. There's a lot of work being done on what's called cryocompressed gas. That's supercritical gas that's down at like -2, I think it's 213 degrees C. And it's still in gas form, but it's super cold. The thing about being gas, you cannot compress a liquid, but you can compress a gas. So if you cryocompressed to 400 bar, you end up with more molecules in the same space than you do for either liquid or for 700 bar compressed gas. So that innovation's coming. It's not there yet, but they're working on it, and they're going to see where that one goes as we move along.
And I look forward to discussing those new products and new innovations with you when we're able to.
Yeah, absolutely. Sure. So, Chuck, I've got a great listener question here. I think this is fantastic. It follows on nicely from some of the things we've already discussed around the technical side and the challenges. So, if you were to describe a fully mature and let's say able infrastructure for the hydrogen sector, what might that look like? I mean, what systems and components would be involved? How would it all work?
I would say having a very consistent, solid, large-scale PEM electrolyzer, or electrolyzer. Let's put that in general. There's 3 or 4 technologies that are really mature on the market today. So it could be PEM, it could be alkaline, depending on what your power source is. If you're coming off nuclear, alkaline or water, or coming off a hydro, alkaline electrolyzers can work really well, but you have to have very, very clean power. You can't have green power on most alkaline. There's a few that claim they're getting there yet. I haven't seen them. But you've got PEM, which can deal with green inputs or standard inputs. We see AEM, which is anion hydroxyl membranes. They're very small, but you put a whole bunch of them together and get a lot larger output. Those are very popular, very inexpensive, very quick to get deployed. We've seen systems that have gotten out from design to in the field in 9 weeks. So that's a really neat process. And then finally, there's solid oxide. And those are being used mostly in government deployments around the world. And there's a few companies that do that. Very low OPEX once you get running on them. But those all will bring you very consistent, solid electrolysis, get you a significant source. Some places we see, if you're going to be dealing with like the high heat applications, and this is the place that we really need to target, is our steels, is our cements, is our glass, is our distillation towers at refineries. Those you can have the gas source right nearby. You don't need to transport it. Those are the ones you don't hear about, because those aren't the ones the public will normally see. The ones public will see is transportation. So we'll have bus fleets, truck fleets, and so forth. And what I see really to mature out, before we start putting stations everywhere so you can go fill up your own car, we're going to see fleets. So fleets that come back to station at night or go station to station on their own network, with stations built and electrolysis on site, those are the ones that are going to be successful to start off with. It's going to be exactly the same thing that happened when we deployed natural gas. Then eventually you start building out your long road solutions. Europe has got a great plan. They've at a stations already open. I believe Germany has in the neighborhood of 280 stations. Not all of them at high pressure for trucks, but at least there's gas available. There's a plan to add stations to get us all the way up to Finland in the near future. And those monies have been allocated. So that's important. So get the fleets going first, then you go to long hauls and additional places to fuel, and that'll be important. The nice thing about the stations is if they're on site, you can manage your back-to-back fillings. You can manage the size of your buffer tanks, so you know pretty much how much you need. When you start getting into, say, a truck stop, your amount of gas you need to store and make is going to be variable on who pulls in. You don't know who those people are going to be and when. So I think maturing out the industry is going to start there, and then we're going to go from that point forward.
Great to get that vision.
Yeah, really is. So if that is your perfect system and your perfect infrastructure behind the hydrogen sector, how is it that Swagelok are playing their part in making this desire a reality?
We work with many of the major people that are parts of those components, whether they be electrolyzer manufacturers, whether they be transport companies that are actually moving gas around, and those could be everything from cryogenic to gaseous. In the United States, we're on a large majority of the gaseous tank trucks. In Europe, we've now got some certifications coming that'll be able to get us onto a lot of the ones there. So we'll be in that area helping. We help on buses and on trucks in many different areas around the world, and help to build those systems out, help to make those systems efficient and effective, delivering the components that are there to be able to make those work. And then finally, on the infrastructure portion, really helping the companies that build the dispensers and the compression systems. Right now, there are problems with components around the world. If you talk to people, the reliability of a lot of the components is not very high. Hydrogen is difficult to do. Something that's going to work on water under your sink is not going to work for a hydrogen system at high pressure. So making sure you're working with suppliers that know what they're doing and know how to make that whole system work is really critical.
Absolutely, and some great advice there as well, Chuck.
Yeah, absolutely. Now, I think I want to come back to some regional perspectives. You talked a bit about that at the start of our conversation today, Chuck, and we know that you've been on the road quite a bit. So I guess what regions are you seeing particular demand from and are clearly scaling up their hydrogen ambitions or their rollout? I mean, you've already mentioned Germany and Finland and parts of Asia, but perhaps you could give us a bit more meat on the bone on some of those specific countries or regions.
Sure. So India is huge. India right now has a plan. Just one in particular company, they're a large chemical company, plans to convert 8,000 trucks by 2027. So if that's the case, that'll be the largest hydrogen truck fleet in the world. Now, the technology they're planning on using is ICE engines, which means internal combustion engines. So they're kind of going on a midway technology here. So you can convert a diesel engine to run on hydrogen. And if you do that, you've saved a lot of money on the high cost electronics, the fuel cells, and the drive systems. But you're still cleaning up that exhaust dramatically. So that's one big place we see coming. And of course, they're going to need stations and infrastructure to go along with that. And we've been helping a variety of the companies there do all their on-vehicle work and working with some of the infrastructure folks as well. So we see that as coming along very quickly. And if that comes, the nice thing about India is if you're a very large company with a lot of money, the government likes you to help out doing this, and they want to make that happen. India really had a moment during COVID when they could see the Himalayas for the first time from Delhi in 2 generations, and that really struck some people strongly. And they're really concerned about cleaning up their environment. So we see that, and they have CNG coming. There are massive amounts of CNG happening in the country too. Again, Indonesia finally getting off the ground heavily. They had their second major Congress meeting or ecosystem meeting, like I said, about a month and a half, 2 months ago, and they're going to be going pretty quickly. Canada, of course, by province is coming. Alberta and is coming along very well. British Columbia has always been active, so they'll be moving along as well. And then U.S. is going to be I can tell you in 2 weeks what's going to happen. Really, honestly, until this next U.S. budget happens and we find out whether the generation tax credits are going to be in place or not, then we'll know how quick it's going to go. If it does, if the tax credits stay in place, then the hydrogen hubs will be taking off. And that's going to be 7 locations around the country that have about a $9 billion investment from the government and at least 4 times that from private industry to manufacture hydrogen at location and build out the whole infrastructure. So that's going to really help in North America. Again, Europe, Hydrogen Europe, and European councils are doing a lot of work to make sure their backbone project, which is what the pipelining project is called, is coming up to speed. So there's going to be a lot of movement of hydrogen by pipeline throughout Europe. And that's going to help because then you don't need to truck it as far. You can get it to a point and then move it a few kilometers, up to 100, and then you're easy. It's at that point to keep stations filled, to keep that gas moving. And then finally, of course, there's a lot starting to happen in South America, but a lot of those are proof of concept items right now. So we do see things happening in Uruguay, believe it or not, in Chile, in Brazil, and Argentina coming along. And some of those places are going to end up being mine sites that they want to help clean up. And that's some great moves that are happening there. All heavy-duty vehicles off-road, which means they need everything to start with. South Africa's been doing that for a while as well. So around the world, people are still trying to meet their Paris Accord commitments, and this is one of the big ways they're going to be able to do it.
That's fantastic. What around the world there and a whistle-stop tour. Great.
Yeah, a real world tour. You mentioned the IRA and the news coming out of the US there. We actually covered that on a podcast quite recently. So again, listeners, do be sure to go back and listen to that. You also mentioned a few regions there. Rob, I know we've spoken on the podcast before about perhaps doing some regional deep dives.
We have indeed.
I think that's given us a few ideas there. Canada, India, South America. We'll have to dive deep and shine a spotlight.
Sounds like we need a Swagelok corner in those episodes.
Yeah, I certainly think we do.
One of the nice things is we're all around the world. We're in 70 countries and sub offices in many of the rest. So we're almost everywhere in the world, and we're there to be able to support in local language what those needs are.
Well, we know where to go, so do our listeners.
We certainly do. So Swagelok are all over the world. But Chuck, how about you? What's your next trip? Are you going to be all over the world in the next few months?
Actually, I'm going to be in Houston in a few weeks, speaking at the big hydrogen show there, and then I'm going to take a little bit of vacation time, I think. So, and then the schedule will come up as needed. We're here to be there for customers as needed. We'll be probably speaking at a few other shows as the year goes on. We're just trying to put that list together. Can't do all of them. There's a different show or conference going on every week somewhere in the world. You can't do them all, but we're working on that. We're helping build that out. So I'll probably be doing a lot more training internally as well to help make sure we've got more experts to help in more regions, and that's important to us as well.
And we'll have to nail down a time to catch up with Chuck again in the second half of the year. Yeah,
we certainly will. Thank you for joining us, Chuck. Always great to have you on the 1895 podcast and discussing hydrogen with you, but we'll let you get back to your day and we'll catch up in a few months' time.
All right. Thank you.
This episode is sponsored by Swagelok.
Managing hydrogen safely and cost-effectively while meeting performance benchmarks and reducing downtime is critical to building a sustainable clean energy future. That's why industry leaders trust Swagelok. With Swagelok, your team is a lot bigger. You have access to hundreds of fluid systems experts around the world who can keep you and your systems online and operating efficiently. Learn more at swagelok.com/alongside you.